Hello guys, this is a Wittig reaction video lecture series, and this is a part 5, and I have already made 4 parts about Wittig reactions. In part 1 I described what is Wittig reaction. In part 2 I discussed what is ylide, how ylide is formed. In part 3 I discussed what is the mechanism of Wittig reaction, and in part 4 I described how we can use a retrosynthetic analysis to do Wittig reaction. In part 5 I'm going to describe some examples of Wittig reaction to clearly understand further more about this reaction. So you need an ylide and a carbonyl compound. It could be aldehyde or ketone, and in this case we have a ketone. So the bond will be formed between carbon number 4 and carbon number 1. That's there, and this ketone will be converted into alkene. That's there. Now this alkene is interesting. It could be cis or trans, so you decide. I'll leave it to you, or put the answer in your comments whether or not this alkene is cis or trans. I'll be checking your answers. Now the interesting question should be how we can control the stereochemistry of the Wittig reactions to exactly or stereospecifically get the desired Z or E alkene or cis or trans alkene. I'll make next video in where I will discuss the stereochemistry of Wittig reaction briefly. And this is a very interesting example in intramolecular Wittig reaction. So you have a chain of carbons based on 7 carbons, and you have an alkyl halide and a ketone in the same compound. All right, previously what you see that you generate ylide from alkyl halides, and then you react ylide with ketones to give you the alkenes. Now in this reaction you don't have to separately generate from a different compound ylide, but still you have to generate ylide. So this number 1 should indicate that first this alkyl halide part will react with this ylide, and the negative charge will be on carbon number 1, and the base will do this job. It will deprotonate this proton and will put the negative charge at the carbon 1, and the negative charge will take on the carbon number 6 to give you a 6-membered cyclic alkene. And this is how you can prepare endocyclic double bonds from Wittig reactions. People often wonder that we can only prepare exocyclic double bond. This is an exocyclic double bond, and this is an endocyclic double bond. So you can prepare both type of alkenes, both type of double bonds using Wittig reactions. It could be either exocyclic. Exocyclic means a double bond which is outside the ring, as you can see in this example. And endocyclic means a double bond which is inside the ring, as you can see in this example. And the primary difference between these two reactions is one is intermolecular between 2 molecules, and one is intramolecular between 1 molecule. So you have an inbuilt system where you have an alkyl halide and a ketone, and you generate ylide in situ using this system, and then you the negative charge attacks on this carbonyl carbon, and then you get the product. I hope you like this video, and if you have any questions regarding Wittig reactions, please drop your questions in the comments below. Thanks for watching. Bye.